All right, so today in geometry, we are going to review solving equations from Algebra 1. These are skills that we need all year long in geometry, so we're going to make sure that we remember them. So first, we're going to look at solving one-step equations. So step number 1, you want to perform the operation to get the variable alone, which just means undo the current math operation. So remember that multiplication and division undo each other, and addition and subtraction undo each other. So number 1, solve 3y equals 21. It says 3 times y. The opposite of multiplication is division. So I would divide this side by 3. Whatever I do to one side of the equation, I have to do the other. So I divide this side by 3. So here, 3 divided by 3, they cancel. That's why we did that. And we're left with y equals 21 divided by 3, 7. So our answer, y equals 7. And I've shown my work there. Remember that we are showing all steps. Number 2, x plus 10 equals 25. So the opposite of addition is subtraction. So I need to subtract the 10. So subtract the 10 from both sides of my equal sign. So over here, my 10s cancel each other out, and I'm left with x equals 25 minus 10 is 15. So my answer, x equals 15. Number 3, I have 1/4 y equals 3. I have a fraction, and really it says 1/4 times y, so the opposite of multiplication is division, but dividing by a fraction is the exact same thing as flipping that fraction and multiplying by it. So since I need to get rid of the 1/4, if I flip 1/4, I get 4/1. So if I multiply both sides by 4, on this side, the 4 times 1/4 is just 1, so I'm just left with y equals 3 times 4, 12. So those are solving our one-step equations. So now let's look at solving two-step equations. And so this is where it takes 2 steps in order to get the variable all by itself. So step number 1, we want to isolate the variable, which means get it on a side all by itself. Again, this is done by undoing all the operations. We do PEMDAS backwards to accomplish this. So we would start with subtraction, then addition, division, multiplication, exponents, and parentheses. And then we will perform the appropriate operation to get the variable alone. And don't forget to make sure that your answer is in the same format as your original problem. And we'll see what we're talking about that here in a little bit. So solve these. Number 1, 5y plus 17 equals 32. So the very first thing I want to do is get rid of that 17. It's being added, so the opposite of addition is subtraction. So I'm going to subtract 17 from both sides. So now on this side, my 5y is still over here, so it comes straight down. My 17's cancel, and I have 32 minus 17, which is 15. So now I have a one-step equation that I've created. My variable's not by itself yet, so I need to get the y by itself. It says 5y, so that's multiplication. Opposite of multiplication is division. So I'm going to divide this by 5, which means I have to also divide the other side by 5. So now my 5's cancel, and I have y equals 15 divided by 5 is 3. So my answer, y equals 3. And again, this is the work that you must be showing in order to. Number 2, 7x minus 3 equals negative 28. So again, first I need to get rid of that minus 3. It's being subtracted, so I want to add 3 to both sides. After I do that, the 7x comes straight down. Negative 3 plus 3, the 3's cancel. On this side, negative 28 and a positive 3 gives me a negative 25. So now it says 7 times x, so I need to divide by 7, divide by 7. So 7x divided by 7, my 7's cancel, I'm just left with x equals. So now on this side, negative 25 divided by 7. That is not a nice whole number. So this is where we need to come back up here, and it says don't forget to make sure that the answer is in the same format as the original problem. So I look at my original problem. This problem all started out with whole numbers. Therefore, I get to pick how I want to put my answer. If the problem had started out with fractions, and when I got to the end, my answer was not going to be a whole number, I would leave my answer as a fraction. If the problem had started out with decimals, and I got to the end, and my answer was not a whole number, then I would have to give it as the decimal answer. So here, I could have more than one answer. I could leave it as negative 25/7 because 25 and 7 don't have anything in common. Or I could go ahead and divide that out and put it as a mixed number. So 7 goes into, let's see, 25 3 times, so negative 3 and then I would have 4/7 left over. So that's a mixed number. Or I could put it as a decimal. So if I put it in my calculator, negative 25 divided by 7, that would be negative 3.57. So on one, where all of my numbers start out being a whole number, my final answer is not a whole number, I can pick how I'm going to write my answer. You will see me do it this very first way because I absolutely love fractions, and so I always use fractions. All right, let's flip our notes over. So number 3, 3/4 x minus 12 equals negative 6. So first thing I need to do is get rid of the negative 12. So it is being subtracted. So the opposite of subtracting is add. So I'm going to add 12 to both sides. So on this side I'm left with 3/4 x equals, so now negative 6 plus 12 gives me a positive 6. I have a fraction, 3/4 x. So remember we said to get rid of a fraction, you take that fraction, you flip and multiply. So I'm going to multiply both sides by 4/3. So here they cancel. I'm left with x equals. So I have 6 times 4/3. There's more than one way I could do this. I could do 6 times 4 and get 24 and then divide that by 3 to get 8. Or I could reduce. If I did 6 times 4/3, I could say, okay, I can reduce numerators with denominators, tops with bottoms. So this 3 on the bottom goes in that 6 twice. So now I have 2 times 4 is 8. You see, either way I get the same answer. So x equals 8. All right, number 4, 1/2 y plus 3/4 equals 2/3. All right, so we're going to practice with fractions. Again, I love fractions. We use fractions all year long, so you will find that we have lots and lots of fractions in this class. So the first thing I need to do is subtract 3/4 from both sides. So now I have 1/2 y equals, so here I have 2/3 minus 3/4. Remember with fractions, I need a common denominator in order to add or subtract. I have a 3 and a 4, so my common denominator is going to equal 12, 3 times 4. So I need to put this over 12 minus this over 12. So I had to multiply 3 times 4 to get 12. So whatever I had to do to the bottom, I do to the top. So here I multiply top and bottom by 4. So 2/3 is the same thing as 8/12. Now here, the bottom I would have to multiply by 3, so the top I multiply by 3. So on top, 3 times 3 is 9, 4 times 3 is 12. So 8/12 minus 9/12 is negative 1/12. So now I need to get rid of this 1/2. It's a fraction, flip and multiply. When I flip 1/2, I get 2. So multiply both sides by 2. I get y equals, I have a 2 on top, a 12 on the bottom. That 2 is going to go that 12 6 times. So I get negative 1/6. It's not a whole number, so I look back at the original problem. The original problem had fractions, so I must leave this as a fraction. No decimal on this. Okay? Right, let's go on to number 5. 5y plus 4 equals 2 times y minus 6. The very first thing I need to do here is distribute that 2. So over here I have 5y plus 4 equals 2y minus 2 times 6, 12. Now it doesn't matter, okay, what I do next. I need to get all of my variables on the same side. I have a 5y and a 2y. I like to move the smallest variable over. That way it helps eliminate negative numbers. So 5 and 2, the 2 is smaller. I'm going to subtract 2y from both sides. And you see I'm going to write that underneath the y over here because I'm only subtracting 2y with 5y, not with the 4. So 5y minus 2y, I have a 3y. So this is a 3y that's left here. This plus 4 comes straight down. Here my 2y's cancel and I'm left with negative 12. Now I'm trying to get the y by itself, so I want to subtract 4 from both sides. So here I have a 3y, negative 12 and a negative 4 is a negative 16. Divide everything by 3. It's not going to give me a whole number, so I look up here. I had all whole numbers, so that means I get to pick how I'm going to put my answer. So I'm going to put it as negative 16/3 because I prefer fractions. You could have changed it to a mixed number, which would have been negative 5 1/3, or put it as a decimal, negative 5.33 repeating. Right, let's look at one like number 6 now. X plus 1, the whole thing divided by 5 equals 2. I want to go ahead and get rid of this denominator. So whatever's in the denominator, if I multiply everything by that, it goes away. But remember, whatever I do to one side, I have to do to the other. So if I multiply everything by 5, 5 on top, 5 on bottom, cancels. I'm just left with x plus 1 on this side. On this side, I have to multiply by 5, so 2 times 5 is 10. And now look, we have created a nice and easy one-step equation at this point. So now I just need to get rid of this plus 1, so I'm going to subtract 1 from both sides, and I get x equals 9. There's our answer. All right, let's look at number 7. 2.3k plus 6.2 equals 10.8. Very first thing I need to do is subtract 6.2 from both sides of my equal sign. So over here I have 2.3k. The 6.2's cancel, so 10.8 minus 6.2 is 4.6. Now I want to divide everything by 2.3. So 4.6 divided by 2.3 happens to be a nice whole number. It's 2. If it had not, I would have given my answer as a decimal, since the original problem, all started out as decimals. All right, number 8, 11.1 plus 6x. Everything divided by 2, all of that equals 12.4. Again, I want to get rid of my denominator. It's a 2, so I'm going to multiply everything by 2. Over here, top and bottom, the 2's cancel, and I'm left with 11.1 plus 6x equals 12.4 times 2 is 24.8. My goal is to get the 6x by itself, so I'm going to subtract 11.1 from both sides. On this side I have a 6x. Over here we're going to get 13.7. So now I need to divide everything by 6. If this is not a whole number, I'm going to leave it as a decimal, since the original problem had decimals. 13.7 divided by 6 is about 2.28. The original problem had 1 decimal point, so we're going to go to 1 decimal point. So we're going to make this approximately 2.3. My approximate signs let me know that I've rounded this. All right, number 9. 5 times x plus 1 over negative 2 equals 3x minus 12, all that over 4. So let's look at how do we handle a problem when we have a denominator on both sides. The very first thing we see, we need to distribute that 5. So I'm going to get 5x plus 5 over negative 2 equals 3x minus 12 over 4. This is what's called a proportion. Remember, with proportions, we cross multiply. So if they both have a denominator and you only have one fraction equal one fraction, cross multiply. So here I would have 4 times 5x plus 5 equals this denominator, negative 2 times this numerator, 3x minus 12. So now I need to distribute. So 4 times 5x gets me 20x. 4 times negative 15 becomes negative 60. Equals negative 6x, negative 2 times negative 12. Oh, sorry, I need to go back to that. That's not a negative 60, that's 4 times, right, let me see. That's 5x plus 5, so that becomes 4x times 5, which becomes plus 20. Sorry about that. This is a plus 5. So 4 times 5 gives me 20. So negative 2 times 3x gets me the negative 6x. Negative 2 times negative 12 gets me plus 24. Again, I have a 20x and a negative 6x. The negative 6x is smaller, so I'm going to move it over. So I'm going to add 6x to both sides. So now on this side, I have 26x. My plus 20 comes straight down, equals 24. I need to move this 20 over, so I'm going to subtract 20 from both sides. I have 26x equals 24 minus 24. And now I need to divide by 26. So I have x equals 4 over 26. The original problem, they were all whole numbers, right? So I get to pick. However, if I leave it as a fraction, which I have to make sure it's simplified. So 4 and 26, I can reduce that. They both have a 2 in common. So 2 goes into 4 twice. 2 goes into 26 3 times. So I would put x equals 2/13. If you put that as a decimal, you would have to tell me x is approximately 0.15. All right, so that is our first day of notes, reviewing how to solve equations from Algebra 1.